Okay, this video we're going to be looking at dilations. Dilations basically are just a reduction or an enlargement of a figure. The scale factor is the ratio by which the figure changes. A little bit more with vocabulary over here. Reduction, these are dilations with a scale factor that is less than 1, keyword there, less than 1, are smaller than the original shape. If I'm multiplying it by something that's less than 1, it is getting smaller. So in other words, like a fraction. An enlargement, dilations with the scale factor that is more than 1 are bigger than the original shape, because if the scale factor is bigger than 1, it's going to be getting bigger itself. All right, so let's look at some examples here. So reduction or enlargement, first of all, k is the scale factor. So k is 1/2. It is less than 1. So this is a reduction. And I'm going to write that as, I'm going to put the scale factor here, 1/2 of k, 1/2 of y. Then what I'm going to do is take this ordered pair right here. I've got 18, 5 as far as my ordered pair goes. And I'm basically going to find, in order to find the new ordered pair after I reduce it, in this case because it was a reduction, I'm just going to simply multiply each one of those ordered pairs by the scale factor, which is 1/2. So 18, half of 18 is 9. Half of 5 is 2.5. It's my new ordered pairs there. So over here, half of 22 is 11, half of 12 is 6. And that's all I have to do for scale factor. All right, so let's look at our next one here. I've got a scale factor of 4, so that's going to be enlargement because it's bigger than 1. So I'm going to put that scale factor 4 next to each my x and my y. And now I'm going to do the same thing, except for instead of taking half of it like I did here, I'm going to multiply by 4. So I have 18 times 4 is 72. 5 times 4 is 20. So that's my new ordered pair there. My next one, I have 22 times 4, which is 88. And 12 times 4, which is 48. And that's my new ordered pair there. Okay, let's come over here to this side. We're going to find the scale factor, see what's going on between triangle A and triangle B. So triangle A is my original shape. We can see where it is here. Triangle B is this smaller one here. So I already know it's going to be a reduction because it's getting smaller. Then what I like to do to find scale factor is basically I just find two ordered pairs, one from A and one from B. That's kind of easy to work with here. So I'm going to look at this point for A, which is at 0, 3. So A is at 0, 3. For the second triangle here, little b here, I have 0, 1. Okay. So then all I have to do now is set up my fraction. I've got new over old. So 1 over 3, because the new one was 1, the old one was 3. So I have a scale factor of 1/3. Okay, let's try this again. Again, I'm going from A to B. So this time it's enlarging. Enlargement. So A and B. I'm just going to pick two ordered pairs here. So maybe this one looks like 2, 2. And for B, I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have 5, 5 for triangle B. Again, I want new over old. So the new one, the big one, I have 5 over 2. So I could leave it like that if I wanted to. I could leave it a fraction, 5 over 2, or I could divide that out and do 5 divided by 2, which would give me 2.5. So either which way, you could see a scale factor of 5 over 2 or 2.5. Again, it makes sense that it's an enlargement because both of these are greater than 1. Okay, last few here. It says point A is the original point. Point R is the point after the dilation. So old and new, old and new. So what I'm looking for here is to find the scale factor. So again, I'm going to be putting new over old. So I just pick one here, 9 over 3 is 3, and that's my scale factor. Try this one over here, new over old. I have 6 over 9. When I simplify that down, I get a scale factor of 2/3. All right, so I need to find the new points when I'm given the scale factor. Scale factor is 2, which means I just need to multiply each one of these points by 2. 1 times 2 is 2, 1 times 2 is 2, 3 times 2 is 6, 1 times 2 is 2. That's all there is to that. The last one here, I have a scale factor of 1/4, which means it's going to be getting smaller. Reduction. I always kind of write that off to the side just to make sure. So here's my triangle as it is right now. So I want to see what it's going to be like when I simplify it down or I reduce it by 1/4. So what I'm going to do is write down my ordered pairs as they are right now. See where we're at here. So I have 0, 1, 2, 3, 4. B is at 1, 2, 3, 4, negative 1, 2, 3, 4. So I have 4, negative 4 for B. C is at 1, 2, 3, negative 4, negative 4. Okay, so now I'm going to take 1/4 of each one of these, or in other words, to find 1/4 of something, I'm just going to divide it by 4. So 0 divided by 4 is still 0. 4 divided by 4 is 1. 4 divided by 4 is 1. Negative 4 divided by 4 is negative 1. Negative 4 divided by 4, negative 1. Negative 4 divided by 4, negative 1. Now I can plot those points. So here's my new A, my new B, my new C, and I can see that, yes, it is in fact a reduction. So that was notes on dilations.